Well, this is exciting to build off of Daniel's talk that is sort of applicable to all agriculture and sort of level up one to focus on the types of products that we may be able to shift consumer demand for towards inherently lower carbon types of food products. So I'll be talking about the alternative protein sector, which encompasses all sorts of drop-in replacements for products derived conventionally from animal agriculture. So meat, eggs, and dairy alternatives are all within this bucket. As many of us know, I'm sure this is not new information, the challenge with animal agriculture as it relates to sustainability and greenhouse gas emissions really comes down to this, that animals are fundamentally inefficient protein producers and that the vast majority of their caloric intake is being expended through their own metabolic processes and general day-to-day maintenance rather than being stored in the form of edible food. So this, of course, is where a lot of this inherent carbon footprint of animal products is coming from. And we see that manifest, of course, in terms of greenhouse gas emissions per 100 grams of protein for each of these various products. So this chart here captures a wide range of different systems for producing these various food products. And you can see that even in the best of cases for animal proteins, these are still more carbon intensive than even the kind of worst case scenario for plant-derived proteins. So this inefficiency and this carbon footprint, among other sort of environmental implications such as eutrophication and pollution and so forth, is really inherent in the inefficiency of cycling calories through animals. These carbon implications and climate implications are, again, not something new, not something that we're just learning about. There have been decades of growing awareness campaigns to educate consumers on the implications of animal protein-rich diets from an environmental perspective. And yet, when we look at the trajectory of growing meat demand globally, we really have seen no sign of slowing. We're looking at close to a doubling of animal protein demand in the next couple of decades, which is simply not doable with current practices. So the solution that the alternative protein sector brings forward is, rather than trying to convince people to change their dietary behavior and choose to eat more plant-rich diets, let's actually flip the question on its head and say, can we make meat, dairy, and egg products in a different way? Can we make products that, from the consumer experience perspective, are essentially the same, offer that same flavor profile, same nutritional profile, that same consumer experience, but are made from either plant-sourced ingredients, fermentation-derived ingredients from microbial species, or cultivated directly from animal cells. These various forms are in different stages of maturity in terms of their penetration into the market. Of course, we've seen great traction for plant-based products. I'll show just one slide of many that I could use to demonstrate the sort of hockey stick curve that we're seeing there. Fermentation is increasingly being recognized as a tool to provide flavoring components as well as texture and structure components that can make really compelling products. And then cultivated meat from animal cells is just taking off. We only saw in the last 5 years the first startup companies arise in this realm. But we've now seen, just as of a few weeks ago, the first commercial product launch in Singapore. And there are now over 65 startup companies working on cultivated meat. So we've seen immense traction in the marketplace for alternative proteins. The success of products like the Impossible Burger and Beyond Burger have really sort of opened people's eyes to the category, and not just consumers, but also the incumbent food industry, including the incumbent meat industry. So this is a graph, obviously, over a very long time scale of new product launches of alternative protein products. And you'll notice in the last just 2 years, a very rapid uptick, of course, But if you look at some of the names of the companies that are putting out these products, you'll notice the major players in the conventional industrial animal agriculture industry. So companies like Tyson, Purdue, Hormel, Smithfield are all recognizing alternative proteins as a new growth engine for their companies, and really genuinely kind of rebranding themselves as protein companies rather than meat companies. Now, this slide here reflects trends in the US, but this is truly a global phenomenon. We're seeing the same sort of consumer receptivity and market receptivity for alternative proteins really around the world, including in markets that you wouldn't necessarily think of as sort of, innovative leaders in novel food trends. So we're seeing immense receptivity. The question now is, how can we accelerate this trend? So what are the bottlenecks to growth for the alternative protein industry, and what's to be done at a sort of systems level to push us closer to that more sustainable protein transition as quickly as possible? And what I've been seeing over my last 5 years working in this industry is that the alternative protein sector is handicapped actually not by limits in consumer demand, but by R&D resources and manufacturing capacity. We're now seeing consistently across many geographic regions globally more consumer demand than companies are able to ramp up and meet within the time scale that demand is increasing. So I'll touch just quickly on some key market challenges that I think federal efforts can help address to accelerate this transition. So the first really has to do with constraints throughout the supply chain. Our current agricultural supply chains are to a large degree optimized around feed commodity crops for animal agriculture. And alternative proteins will really require us to sort of rethink that paradigm and explore things like novel crop development, new innovations in how those crops are processed and fractionated to derive different biomass streams, whether that's a protein enriched stream or starch or carbohydrate enriched side stream. There's a huge demand for new predictive tools to help deal with seasonal variability and regional variability in the inputs to these processes. And this shift in demand for various biomass fractions will really be happening across the whole bioeconomy. So I love that we're having this conversation in the context of looking at green chemistry and other bio-based manufacturing processes. The second area is production capacity limitations. So this again crops up over and over as truly a bottleneck for the rate of growth of the alternative protein industry. A lot of these products are made using fairly outdated, if I'm being candid, manufacturing methods, high moisture extrusion, for example, that aren't necessarily really optimized to this application area. And there's immense room for optimization throughout production of both the raw materials and the end products. And then finally, there's a fair degree of information gaps across the industry. So this relates to both market information, obscurity of trading markets for some of these inputs and so forth, as well as kind of research or fundamental information gaps in the research space. So if we look across the whole supply chain, there really are opportunities to improve upon both scalability and to further improve sustainability, all the way from sort of initial crop harvest or initial cell line development in the case of microbial fermentation or cultivated meat, all the way through to the processing of those, production of end products, and then looking further on down the chain in terms of distribution and so forth. So all of these areas I think are ripe for integrated innovation that can improve the sustainability of each of these steps in and of themselves, and then at a meta level, improve sustainability of our food system overall by accelerating the shift towards these more sustainable food products. I feel that interdisciplinary research centers, and especially something along the lines of a manufacturing innovation institute for alternative proteins, really should be considered mission critical to advancing this. I think this really is on par with, you know, other kind of major government investments into new and cleaner manufacturing areas. I think there's a strong argument to be made for an interagency initiative to really prioritize research across the many disciplines and domains that contribute to these efforts, as well as sort of workforce development and training opportunities that would come along with that. And just to give one point of comparison that I'll leave you with, you know, if you look at the amount of global R&D investment into other areas that are sort of within the realm of the type of carbon and climate impact that a shift towards alternative proteins could have, say, look at renewable energy investments. If you look at just a single year, about a decade ago, there was on the order of $250 billion of global R&D investment going into that space. From our numbers adding up across all combined R&D into all of those categories of meat alternatives, so plant-based, fermentation, and cultivated, across all time, public and private investments, we've estimated this is maybe on the order of $1 billion to $2 billion. So we really, you know, are at the moment where I think it's time to create a much more broad consensus around global R&D investment into alternative proteins. So I am at time there, and I will quit there. Thanks.